geometric probability.
Is this the same section?
Same stuff. I'm going to work a little bit with geometric probability today. That's all I want to look at. I know that a lot of people are going to be gone Friday because of the AP Euro test. What I'm looking at doing then tomorrow is a very simple, basic start of 12-4. The very basic, simple start of 12-4 is some compounding and probabilities. We'll talk a little bit about that here in a minute. And then we'll take a quiz on all the first 3.5 sections really on Thursday. Shouldn't take the whole period, no big deal. And then on Friday we'll finish the last bit of the compounding probability, where you can actually do some probabilities in tandem with combinations, NCRs, those types of things. An example of something like that would be, what is the probability of, let's say you have a CD that has 12 tracks on it, and you have 3 favorite songs on it. What is the probability that your 3 favorite songs will play first? Like go in order, 1, 2, 3, and then how would that happen? We'll talk more about that little more complexity of things Friday. So brief, easy quiz Thursday. I know a lot of you guys be out. There's a lot. Actually, I don't know if it's going to be in this period, but a lot. Basically, all third hours is gone because of the AP Euro test. So.
Thank goodness there are no freshmen in that class.
What's that?
Thank goodness there are no freshmen in that class.
Thank goodness.
Yeah, you'll be stuck with the freshman
Anyway, so let's look at this one here, and I want to find the geometric probability, guys. This doesn't take long. I want to get the geometric probability of getting 5 points. Remember, when I'm dealing with geometric probability, I'm looking at the probability of the favorable region. I want the area of the favorable region divided by the total area. So in this case here, if I want to find the geometric probability of getting 5 points, the 5 point is the greenish circle, if you will. I want to get the probability of landing in here.
Oh, these are points.
Yeah. Because what's the radius of that green circle?
3.
6.
Oh, I thought that was 3 for each.
Yeah. Each one of these is 3, so this is 3 plus 3, so the whole radius here is 6. What's the radius of the whole thing? 9. Okay. Now, if I want to find the area of that green circle, I have a radius of 6. So what's the area of that whole circle? 36 pi.
6 pi.
What do I have to back out though?
Minus 9 pi.
Good. So we take the 36 pi, we back out the bullseye, which has an area of 9 pi. That gives you how much? 27 pi is your favorable region. The whole picture there is a square. How do you find the area of a square?
Base times height.
Well, what is it then?
Base height.
They're both 18. Here's why. Well, this much is 9, which means this way is 9, so the whole thing is 9. 18 is math.
Yeah.
I thought you said 8. I'm like, what? So what's 18 squared?
320.
Good. So your answer winds up being 27 pi over 324, whatever that decimal equivalent would be. Yes, ma'am.
Oh, it's the total. Are we going to have calculators on this?
Yes, ma'am.
There's no pi for the total area.
No, because it's a square. What's the big?
The 36 pi, you get that from the
Guys, enough.
The 36 pi, you got it in the green circle, right?
Yep.
And minus the small one.
Right.
Oh, because the shaded region.
I'm looking for this now.
Is the 27 pi over 324, is that as simplified as you want to go, or?
No, just give me the decimal. Whatever the decimal is, it's fine. Okay. Whatever decimal. Round it out near some, whatever it gets out. All right, let's try it again. Just give me the probability. Give me the probability of getting the bullseye. Give me the geometric probability of the bullseye here.
Do those points matter at all, or?
It's just something to say. It's not a big deal.
Okay.
There's different contexts that I can get into with that, but I don't think it's really that big of a deal. Bullseye. Geometric probability of bullseye. For which one? The 36 and stuff? Each one of these pieces here, these arrows are showing that this much is 3, this much would be 6, and this much would be 9. That's all it says. Each individual part is 3.
So you just want,
That's all it is. That gives me a radius of 3 here. This one has a radius of 6, and that one has a radius of 9.
you just want yourself in the middle circle though?
Yeah, it just says bullseye. I want geometric probability of bullseye. So to get the numbers then, if I have a radius of 3, this has an area of 9 pi. This one would be 36 pi minus the 9 pi, because we have a hole cut out of it. And then the largest one would be 81 pi subtract the 36 pi, because it's got a bigger hole cut out. That's all it is. Okay. We're looking at the donut hole problem. Now, if I'm going for bullseye here, the red circle is 9 pi, and we know the whole thing was 324 from earlier. All right? So what do you get? 0.09? Now, let me ask you this. As we get into this a little bit more in depth, I need a quarter. I got a quarter.
I didn't even have a penny to
I
my
need
name.
a flex.
I'm not taking a bribe.
You want a nickel?
Sure, nickel's fine. So, one of the things I want to think about is, as you start to talk about what are called compounding probabilities, if I just flip a coin, what's the probability it's going to be tails?
1/3.
1/2, right?
What if it lands on its side?
What's the probability of
He
that
caught it
happening?
in the palm of his hand and pressed it flat on the back of his hand.
Shut up once you're there.
I'll get them back, no worries.
All right.
So,
I know exactly.
obviously, the probability of it being heads or tails, if I have two, you get 1/2 the time theoretically should be heads and 1/2 the time should be tails. Now, what happens if I want to try to get tails, tails? What would you do?
Flip it twice.
You flip it twice. Are each of those flips independent of one another?
Yes.
So what do you do with those probabilities then? Times them. Because if you add them, what's 1/2 plus 1/2? It's a whole thing. And if I did it 3 times, it would be more than 100%, right? Does that make sense?
So if you time it together, it's 1/4.
Correct. And if you think about it, a real simple idea of flipping a coin, if you flip a coin 4 times, there's only 4 possible things that can happen. Heads, tails, heads, tails.
Tails, heads, tails, heads.
Joe, shut your trap.
I was still caught on the fact that Tommy said time zone. And you were like, yeah, time zone.
Now, the other thing that I found out earlier in the day, Clay, go stand back in the corner.
I know what you're gonna do to me.
I know. No, I have found that your generation has probably not done this before.
I'm feeling over. You got me to solve for that. Wait, how do you do that? I can't actually do it.
Watch your head.
Why are we doing this?
No, it's not. No, I found out that most of you guys probably haven't done that before because how often do you guys have?
What?
How often do you guys carry quarters?
Wait.
Every day of my life.
I don't carry anything else. I want that. I want to try it. Give me back.
It sounds. Somebody have a quarter. The quarter sounds the best.
I have a dime, but I have a quarter, but I have.
I can't even say
I'm just stabbing cheese.
Now, just listen. Just listen.
Well, there's a quarter right there.
I have one. Just listen. I'll get you. Just listen to what it sounds. It sounds awesome.
Is the sound of me screaming?
That's cool.
How?
Violent.
You guys never learned to do that.
I think you never learned to play son of a gun.
We don't know how to aim.
This unit is violent. He got a bow and arrows. He's
I kept my fly.
flinging coins everywhere today.
It's happening.
This is just so unsafe.
I'm trying. Don't put your power on
Look at you. You had a dime too, didn't you?
Yeah.
Somebody else had a quarter. I think it's somewhere around here. We were doing this.
Is 25 cents really important in the grand scheme of life?
It's just fun. It's fun. No, I figured out that most of you guys have never really done that before because you didn't have to have a quarter to call home to say, come pick me up. See if I can do this again. I called fan earlier.
In a very roundabout
I had the fan off the background.
We should call Mr. Fontaine's room.
So let me look at this.
Figure it out.
The sound of hitting him.
Hurt my thumb after a while. I do that all day. They
How do you do it though? I did. I'm trying to not read it.
All right, let's go back to this. And I want to take it a step further and go back into. I want to do the geometric probability of the shaded region. Whose quarter was this?
Base times perpendicular.
I think it was mine. Was it? No, it was you. I'll have it.
Just don't shoot.
Gladly.
I'll take it to try it.
I'll take the quarter.
I'll steer your catch.
I'll take it to try it.
I'm not gonna.
Hey, did I get-
No, I'm not gonna snap it. You're too close. You're too close.
I'll how it looks.
Shoot at me again.
I want you guys to take a minute. I want to find the geometric probability of landing in the shaded region here.
I don't know how to do area anymore.
Well, let's try to remind you guys of some simple areas. We are, and this is still part of what we've been doing. It's in the unit, it's in the section. Geometric probability is in here, so I want to go back and look at some geometric probability. And in this case here, we have two triangles. Are those two triangles congruent to one another?
Yeah.
How?
Side, side, side.
Line say so.
Side, side, side.
You're right, side, side, side.
How do people remember that?
Now, what's the shape in between the two?
That's a rectangle.
Now, let me clear this up from misconceptions from earlier in the day. Do you see any right angles on the triangles?
No,
So
sir.
can you assume that they are right triangles?
Yes, sir.
The only thing you can look at with those two triangles is that they are what kind?
Equal.
They're isosceles. They're not equilateral, they're
I know, I realized
isosceles
that
because
after
we've
I
got the two here. So what I want to look at is, I want to see if you guys remember what happens when you draw the height of an isosceles triangle.
Isn't it
It's
perpendicular?
Perpendicular.
Into what? Two congruent equivalent triangles, correct. What happens to the base?
It's
Cuts in half. It's 5 seconds. So these become 6s and 6. So how do you find that? It is not 3, 4, 5 because would the 5 have to be on the hypotenuse?
Oh, yes.
You do that with
The Pythagorean theorem. And that's the whole point of this problem to be like that, to make you think that it's going to be a 3, 4, 5, and yet it's not. Okay. So here, in order to get the height of the triangle, what I'm looking at here is just Pythagorean theorem. Pythagorean theorem here gives me 64, the square root of 64 minus 36. 8 squared minus 36, or minus 6 squared. That'll give me my leftover side. The 8 is the hypotenuse, that's why I can set that up right away. When I do that, I get the square root of 28. The square root of 28, if you simplify it out, should be rather clean. It's 2 root 7. Okay. 2 root 7 because 4 times 7 is?
28.
Square root of 4 is? 2. So it gives you a height value of 2 root 7. Now, how many triangles do we have? How many, let me rephrase that, how many congruent triangles do we have? We have 2 of them, one on each side here. How do you find the area of a triangle?
1/2 base times height.
So you have 2 of them at 1/2. Our base was 12, and our height was 2 root 7. Everybody okay with that?
Yeah.
What's half of 2? 1. What's 12 times 2?
24.
So the 2 triangles have an area of 24 root 7.
Yeah.
Would that be my favorable region? Yeah. Because that's the shaded stuff. The total area then would be, well, the 2 triangles. And what am I missing?
4 times
The rectangle. That gives me my geometric probability. What I have to do there is just make sure I use the fraction bar so I don't screw it up. That's all. It's not a very difficult thing to look at. It's just a matter of remembering how do you set up some of the triangles. That's all. Okay.
Snap a cord around here.
Nobody's probably just
Like 4.
cannot simplify over addition. Use your calculator, fraction bar. What do you get?
5.7. 0.57.
Silly.
Okay. Just type it in just like that with the calculator, with the fraction bar, and you're going to get it right. So you can try to simplify little puppies. All right. Let me see what you remember about this one.
Oh, it's inscribed. I learned that from
Yay.
Oh my god.
Oh, you find the area of the
Why?
circle and then you
The
subtract the area
Oh,
of the...
I remember doing this.
I don't.
Yep.
The opposed them.
I told you this would be a pop-up. I believed you.
Apple, thumb, apple, potato, potato, whatever.
Tomato.
I don't
I don't know.
All right. Now, the reason why I left this one up, I wanted to put this one up here, because, well, not so much it's difficult. It's that, what's the shape that's inscribed? It's a hexagon, because it has 6 sides. Now, the value of 7 is the radius of the circle. You okay with that? So what's the area of the circle? 49 pi. So we know that's going to be the area of the circle is 49 pi. I have to subtract out the area of the hexagon.
Yeah.
The hexagon was that regular polygon, and it was 1/2 perimeter apical. So we have to subtract out the 1/2 perimeter apical. What's the area of the biggest shape? Which is 49 pi. So now we just have to worry about figuring out the apothem and the perimeter. When you're working with a hexagon, one thing happened that only happened with a hexagon.
The side's the same as the top market.
Not quite. The sides are all the same. The angles are all the same. Remember what each angle measured?
Oh, something
It was
n minus
120. What happens here is that when you draw the radius in, it bisects all those angles. And when you bisect the 120, what do you get? So you have all these 60-degree angles in here, which makes them all, so everything, all the radii and all the sides are congruent to each other only in a hexagon.
So the sides are the same.
So the sides are the same as the radius,
Radius.
not the apothem.
Yeah. The apothem is the dividing, like right angle in the middle, right?
And when I do the apothem stuff, it might be a little bit different than what you guys saw last year. I usually just draw 3 sides and a radius. Okay. Because no matter what, whatever regular polygon you get, you're always going to have 3 sides in a row. No matter what. You don't need to look at the whole picture to figure out bits and pieces. If I know that this side is 7, this was 120, these two are both 3.5, and this is then 60, what's the apothem?
7 squared plus 3.5 squared, no. 3.5 squared plus x squared equals 7 squared.
You're overthinking it, is what kind of a triangle is that in the middle?
36.
Across from the 60, or excuse me, across from the 30 is 3.5, so it's 3.5 root 3 is your apical. You're just using the properties. Stuff you did last year. Okay. We did a little bit of the right triangle trig stuff to get in the middle, beginning of second semester as well. Okay.
So is the perimeter 49?
No, because how many sides do you have in a hexagon?
Oh, 6, so
Six.
it's 42.
Yeah, so this gives you, and when you're doing something like this, you know that your perimeter will be 1/2 of 6 times 7 times your apothem of 3.5 root 3. And all of this goes in here. Okay? When you go to put that in the calculator, use a fraction bar. If you want to type it in directly like you see it, do it. But I can't stress the importance of when you're looking at problems that have more complex things to put together, write down what you're doing before you type it in. Because if you write down what you're doing before you type it in, and that's correct, and then you screw something up, I can figure it out. Yeah.
Would you have us like put this down in the calculator as it is and just skip straight to the answer?
Yeah, did you write that down? As long as you write that down and put it in your calculator, that's all you have to do. Because then you're done. Okay?
Wait, what is my?
Yeah, she'll get over it. I hope.
Where's the I?
Second parrot.
Oh, thank you.
Well,
Just the typing.
it's a carrot top.
That's fine. Did you guys get 0.173?
Yes.
There you go. So the probability, the probability of landing in the, remember what that was called? The shade, but no, remember that was the snow cone problem? Remember the snow cone problem? The crust of the pizza piece? Last year, when you did sectors and all that? You guys never did that?
We did it.
Oh, yeah, we did.
I think so.
Yeah, that was the most annoying subject.
And this was the snow cone? Yeah, arc length stuff? It's all bad.
I was like 90%.
10% time better remember it.
I had first hour though, so I had to.
Yeah, I had first hour too.
I had first hour too. Maybe you get 12 hour next year.
I hope next year I'm not in school.
Dude, you can go on like it's like singing like it's like
Oh, yeah.
Let's change it up. This is the probability of the unshaded.
Oh, dang. So why would they shade it? Why don't they just shade the area that is unshaded, switch the colors?
Yeah, that's a lot less easy.
Please
hold on,
look
we
at
just-
the drawing.
you should how much ink
You
was
did. So give me the probability of the unshaded in this case.
16, 5 times 6.
You know what it is? So you get the unshaded, remember, you're coming across here, that means each of these circles has a diameter of, therefore it has a radius of.
Okay.
So well, that's what you're supposed to, that's exactly what you're supposed to do. So then that gives you a radius of 2, which means the area of each circle is 4 pi. So if I want to do the area of the unshaded, I have an 8 by 12. I have to subtract out 6 of the 4 pi's, which would be? Okay. And I'm going to divide that by what? The 8 by 12 again. And that gives you, what was it, Zach?
0.21. Let's simplify that.
460.
Works for me. So the geometric probability that I'm going to land in the unshaded region is 0.21. Yeah. I guess it's not. snap a quarter at it, see what happens.
Yeah, just don't snap it at me. That one was straight in my face. I had
The corners ones are a little, let's get a little difficult here. What's wrong? Oh, let me say, what did that question?
calling you to get like sway.
I don't have any more paper space. Stop.
You're supposed to say thank you. To compliment you. Like, that's a compliment or
Oh no, I have
No, I've got a couple, I know, this is the one I closed out the wrong tab earlier, that's all.
no, this isn't very.
What was the other one? Oh, I skipped it.
yeah. Oh, yeah, why? Oh, wow.
Oh, it was a geometry one, that's why I closed it. Because these are some geometry problems.
I like flicked it backward, not just exactly
Alright, give me the probability shaded region again.
Coincidence? I don't think so.
Because that's what happened with, yeah, it's what just, it's tangent, it's a line. It's a tangent drawn to the circle. Well, remember the easiest way to tell if it was tangent or secant? If it was a secant, it would go through it because it's secant destroys.
I don't think
Secant goes through a circle because it goes all the way through it, where tangent just touches it in one spot. Secant will go through it like an arrow and it will destroy it.
Tangent is a feature in AutoCAD. It makes circles touch.
Nothing, it has nothing to do with this problem whatsoever.
How does that make you remember it?
Because there's a metallic song, seek and destroy. So seek and destroy. Seek and goes through the circle, destroys it. I mean, it's, try to come up with ways to remember things. What's that?
Oh, that's not right.
No, really? They shouldn't be scary. So the shade.
It looks like a scope.
Oh my god.
So we have
I
what?
love those games.
3, so it becomes 9 pi minus 4 pi. Did you get 5 pi for the shaded region? Oh, whoa, I didn't. Yeah, 5 pi for the shaded region.
What did you do wrong?
Because the shaded region has a total radius of 1 plus 2 is 3. So that'd be 9 pi, and I gotta subtract out, I subtract out 2, I'm sorry.
Oh,
I looked at the 2 real quick, and then I subtract out a singular 1 pi. I'm sorry. Oh, for Pete's sake, I'm allowed to make one
She
something
was
wrong.
asking me what I did wrong, and I did it right, and she did it wrong.
scrub.
And the radius.
So-
goes down 25 pi.
And then the radius of the larger one would be 2 plus 1 plus 2. And then so I divide that by 25 pi. We need some props.
That's not okay. All I've been waiting for.
Wrong.
Math is hard.
It's the wrong math. Not the right math.
Like the other two was good, like. Hey, we're fine. What is he? Hey,
I have to, and you know that one episode of SpongeBob where he has to write an essay and like actually six hours? Yeah, that's more than my AP book right now. For AP year.
On this one,
I'm gonna need one of those.
all I want you to do is numbers 5 through 8, 15 through 17,
They both be, which side?
and then I think it's 22 and 23. Okay? Do those. I will suggest one thing about numbers 15 through 17.
Okay.
When you look at 15 through 17, think of that shape as a track.
Oh, what?
A track.
Running one, like people running.
Yeah. Think of it as a track. Okay? That's a nice little hint. These are all geometric probability. Tomorrow we'll do some very basic